Measles was a common childhood disease in the U.S. before widespread vaccination began in the 1960s. The disease is caused by the measles virus, a negative single-stranded RNA virus with a genome of about 16,000 base pairs. There are 8 coding sequences. The hemagglutinin sequence is the one that attaches to cells and recognizes them. It binds the cellular receptor CD150 that's found on many lymphocytes, or Nectin-4 found on many epithelial cells. Thus, measles will infect a significant number of cells in the body. The large protein, L, is the viral replicase. This accompanies the nucleic acid inside the capsid, and once deposited in the cytoplasm, copies the genome. Unlike the flu virus, viral replication of this single-stranded RNA virus takes place in the cytoplasm. The C and V proteins are interesting because they interfere with the host's response to the virus. There are a number of other proteins, but we're not going to cover them in this lecture. Before widespread vaccination in the United States, measles infected almost all children, producing over 500,000 cases a year. The death rate was about 0.6 per 100,000, which translates to about 949 children in 1948. And again, that's the incidence of the whole population, 0.6 per 100,000. The development of a vaccine in the 1960s caused a precipitous decrease in cases, as you can see on this chart, and the CDC declared measles eliminated from the U.S. in 2000. Unfortunately, measles is making a comeback. Measles is initially acquired through respiratory droplets and enters via the lungs, infecting lymphocytes, dendritic cells, and macrophages, and these are immune cells. These cells then circulate throughout the body, and as virus buds from them, they spread the infection to other cells. After replicating inside the host, the measles virus buds. The virus exits the body by budding from epithelial cells or the skin, thus being spread by breathing and or direct contact with the infected patient. Measles is one of the most contagious diseases known, with an R0 of 9 to 18, meaning each infected individual spreads the disease to 9 to 18 other people. So measles virus epidemics in naive populations can explode and spread very quickly. For comparison, smallpox has an R0 of 6 and influenza 2.5. Victims are infectious several days before the rash is observed, until several days after the rash appears. What does the illness look like? Shown here on this picture is a typical child suffering from a measles rash. And the symptoms of measles are a high fever, the classic rash, a cough, and a runny nose. The rash first appears on the face and then spreads to the trunk and limbs. Complications of measles are the main issue and is the reason we vaccinate against this disease. Measles-associated pneumonia can cause severe illness. In most cases, these cases of pneumonia are secondary infections with another virus or bacterium, but are especially dangerous because remember, the measles virus suppresses the immune system. The C and V proteins interfere with the immune system. Ear infections are also common. Measles itself can also cause death if it infects the central nervous system. ADEM, acute disseminated encephalomyelitis, occurs in 1 to 1,000 patients and is often fatal. SSPE, subacute sclerosing panencephalitis, occurs an average of 7 years later and in most cases is fatal. Measles inclusion body encephalitis is more rare, and in fact, it is something that only happens in immunocompromised patients. Being deficient in vitamin A can increase the chance of complications. Diagnosis and treatment. Measles is diagnosed by rash and symptoms of the disease. The health professional will also take into account the incidence of measles in the area. Treatment is restricted to supportive care, and there are no drugs to mitigate the infection, but patients will be supplemented with vitamin A if needed and watch for the onset of pneumonia. Now, the good news is there's an incredibly effective prevention of measles, and that's the measles vaccine. Measles has been eliminated from the U.S., and progress is being made worldwide with the hope to eventually eliminate this illness. The MMR vaccine, mumps, measles, rubella, is part of the recommended vaccines for children. The vaccine is a live attenuated virus that replicates and provides a robust immune response but does not cause disease. It was first administered in the 1960s. The vaccine is 95% effective if 2 doses are given. And the picture shows a child being vaccinated for measles and smallpox in 1967. That little vaccination gun that they're using was, in fact, I can remember that gun being used on me as a kid when I was getting vaccinated. We've made a lot of progress towards getting rid of measles. As you can see, the number of deaths from measles from 1980, which was 800,000, has massively decreased over the years. And in 2021, we reached a new low. Despite setbacks, we're approaching elimination of this illness, and hopefully we can get there. The last thing I want to mention is the current measles outbreak in the United States. Unfortunately, measles has come back in the last few years with 607 confirmed cases of measles in the U.S. Almost all of these have been in unvaccinated patients, as you can see, and were totally preventable. The increase in misinformation about vaccination spread through the internet and by a few unfortunate notary individuals or individuals of note has made it more likely that people will not get vaccinated, and in the predictable result, there are now more measles cases. I anticipate as people experience the negative consequences of their actions, they will hopefully reverse course. This has happened in Japan in the past with the pertussis vaccine, and hopefully Americans will be wise enough to pay attention and then change their minds. I do expect vaccine uptake to increase. All right, that's it for measles.